Hi everyone, I'm David Wismer. I'm a student in the Metis Data Science Bootcamp, and I recently worked on a classification problem where I built a web app that I'm calling Genrefy that classifies different songs into their EDM subgenres using the Spotify audio features. So let me go ahead and pull it open. I don't know how to run it globally yet. I can only do it on my machine, and that's because of authentication issues with Spotify. So I'm just running it locally with Streamlit. Let's go ahead and pull that open. So I'll show you how it works, and then I'll go through some of the code on my GitHub as well. When you open up the page, what you see here is a drop-down menu with a recommendation classifier, a playlist classifier, and a track classifier. We can start out with recommendations. What this does is it takes up to 5 seeds for recommendations, and it'll return 100 Spotify recommendations sorted into, or rather classified into, their different EDM subgenres. You'll see what those are here in a second. So we could start with a simple one. If we select EDM, how does Spotify recommend songs? What does it spit out? If we click Genrefy, what we'll see here is a breakdown and then also the detailed list. We can go ahead and get rid of this sidebar. So this says that Spotify returned dubstep 39% of the time, deep house 23% of the time, trance 12%, etc. We've got drum and bass, techno, progressive house, and hardstyle in our genres as well. And then here are the actual 100 recommended tracks, each of them with their genre prediction. So we could start out with EDM, but also you could put in anything. So we could put in something like country music, for instance. If we hit Genrefy on this is going to give us 100 recommendations as well, but you'll see these are actually country songs. I mean, I don't know any of these country artists because I don't listen to country music, but they certainly seem like country names to me. But you'll see they're trying, the app is trying to classify these as EDM songs based on their audio features. So maybe a country fan might be interested in looking into deep house or dubstep as their introduction into EDM music. You could also enter artist URIs and track URIs. So a URI is like a unique identifier for some Spotify entity. So if we open up the Spotify app, grab, for instance, Above and Beyond, if you click the Option key on Mac, or I think it's the Alt key in a Windows computer, if you copy that and then go back to the app and paste that in here, that was an artist URI. You can see that here, it says artist. And then we click Genrefy. This is going to return, again, 100 recommended songs related to the artist Above and Beyond. So you'll see some Above and Beyond is actually in here, but then also a variety of other artists. Most of what got returned is trance music. Above and Beyond is a very famous trance artist. Progressive house is next. This is kind of like, lower tempo type stuff. Hardstyle is going to be last because this is, very fast paced stuff that's really not going to fit with Above and Beyond style whatsoever. We can put up to 5 different URIs and genres in here. So, we could add in drum and bass. Maybe we want to add in some track that's completely ridiculous. Something from, I don't know, Skrillex, completely different. This is going to be dubstep. Throw a little Justin Bieber in there, why not? So if we put in that Justin Bieber and Skrillex song along with Above and Beyond and drum and bass, and why not, let's add metal. We'll genrefy this, and this will give us a pretty random mix of stuff. You can see we've got some Ted Nugent in here, as well as some Calvin Harris. But again, it does try to predict all of their EDM subgenres. Here's our breakdown. So, with these different mixes of things, dubstep came out the heaviest. Kind of makes sense. Drum and bass and metal are a little more harder styles than Above and Beyond, and Skrillex kind of falls in with that as well. So that's the recommendations part of this web app. We could also go to the playlist classifier. And so what this does is allows you to put in the URI from a playlist. So if we go back to Spotify again, and I have this playlist that I like called Deep House Relax. If I were to copy the URI and paste that in here, what this will return is every single song in that playlist. Here those are, with their expected genre prediction. And as you would expect, you get a lot of deep house and progressive house, 65 and 27% respectively. Very little of these harder styles down here. Makes a lot of sense, as the playlist is called Deep House Relax. Finally, we have the track classifier. So this is something you could use on a single track. So we could do something completely different. Maybe some artist who's kind of doesn't have a set style. Oh, who might that be? Let's do like Chainsmokers. It's a popular artist. So if we do the Chainsmokers, I don't really know their music that well, but let's just take their top song on here, grab the Spotify URI, and paste it in. What this will tell us is the percentage chance that it belongs to each of these different genres in a way. What it really is saying is these are the different votes from our random forest model. 67% of the trees believe that it's deep house, 16% dubstep, etc. So that pretty much wraps up the actual functionality in the app. I'll just go ahead and run through some of these notebooks really quick to show kind of how I built this. It started with gathering the data. So first things first, you do need to have a Spotify developer license in order to do this. And it's not difficult to do. You can Google around and find some pretty easy tutorials to follow to get that set up. The trickiest thing to find out or to figure out for me was kind of the redirect URI, or URL rather. I don't know if this is URI or URL. I think it should say URL. That might be a typo. But in any case, it can be anything at all, but you just need to put it in, and then as you access your app, like Streamlit app for instance, in your terminal, it will ask you where you got redirected, and you just need to kind of paste it in as well, and it needs to match what's in your developer profile. And this is the problem that I'm having with actually setting up a global app, is that I don't have any way of entering in that feedback through my Streamlit launch. So I need to figure that out in order to make this kind of a fully functional app. In any case, for data gathering, you first need to set up your Spotify connection. This is going to require a client ID and secret and username. You specify your scope of what you're going to want to do. For me, I just need to read things. I don't really need to update anything. Then you need to get the features. So here's some functions that help to do that. There's different ways to get the data, and depending on how much you need, there are two different ways to go about it. So this first one here, this is a way of getting Spotify recommendations given a subgenre. So you can give it deep house, it will give you 100 recommended songs back. And what I found was that as many times as I ran through this, I could not get more than 1,000 songs in total for a given genre. And to me, that means, first of all, you're limited to 100 each time you do a run of this. And they'll never go over 1,000, no matter how many times I ran it. So what I had to do for this particular project was get tracks from the different playlists. And what I had to do was kind of curate all these different playlists, go through and find playlists that had deep house in the title, or hard style in the title, hard style hits of the 90s, things like that. Things that were clearly related to a single one of these genres. I wouldn't want to take top 200 EDM songs of 2021, for instance, because what I wanted to do was use the titles as kind of the target variable for my training data and ultimately my testing data as well. So that's how you get the different track URIs. And then once you have the URIs, you plug them into the Spotify API to get the audio features for those URIs. And again, the URIs are the unique identifiers for each and every track. And so then you get all of the audio features back. And I'll show you what those audio features look like in a minute. So here you can see where I created these lists of user-generated playlists. It ran, my functions ran through each and every one of these lists, pulled all of the track URIs for each one of them, and then got the audio features. So here you can see how we did that. Tracks from playlists, get the audio features. We needed to add the genre tags. This is, adding the target variable for the classification model into our data frames. Combined the data frames. Here you can see how many of each of the different genres we were able to obtain. Drum and bass was the least. This was just kind of an oversight on my part. Pick some playlists with not that many songs in them. This becomes a bit of a problem later because we need to balance our classes down to the lowest of to our minority class, which was going to be drum and bass. So this kind of limited my data slightly. And then here's the other way of doing it. You can get the recommendations for each of these different genres. And these are from Spotify, these different formattings here of the genres themselves. So that way I could only see, you can see here I'm kind of capped at around 1,000 even after doing several iterations through this. Once I had that, I got the audio features, added the tags, etc. And then I pickled the data for use in EDA. So next we can check out the EDA workbook. Might take a minute to load. Yeah. Okay. So here are all of the different features that you get from Spotify when you use that audio features API. Duration of the song, acousticness, danceability, yes, seriously. Energy, instrumentalness, key, liveness, loudness, mode, speechiness, tempo, time signature, and valence, which is like a measure of like happiness or something is what I'm gathering. So I brought back in the data. And then, let's see, what are the important steps here? There's just kind of some initial looks into it. Here I was looking at the distributions of the different features. And I was ultimately trying to dig into the data and see, do I need to exclude anything here or any of these outliers worth getting rid of? For instance, here with duration, you see we've got these little spikes over here. These are, probably hour-long plus tracks. They're probably mixes, of, some artists who put together a mix and put it on Spotify rather than SoundCloud. Let's see, instrumentalness, I had to get rid of some stuff. Key, now we're seeing, okay, we've got some categorical variables as well. Liveness, I think I removed a little bit from the top of the range, stuff that seemed like it was mostly spoken word type things. Same thing with speechiness. Tempo needed some adjustment, and I'll get into that in a second. And then time signature, obviously not going to be a very useful variable for us, as almost everything is in 4, which I think corresponds to some particular time signature. Here we've got it in log scale. You can see a little bit more separation, but I mean, for the most part, it's just in that same classification. So the first step I did was I explored some of the lows and the highs. So what I wanted to do was just do a random sample of songs above a certain threshold and below a certain threshold for a given feature, for instance, acousticness. So here you can see I'm looking at, give me 5 songs that are, in the 95th percentile or above, or the 5th and from the 5th percentile or lower. And then, I zeroed in even further to say, okay, well, these all seem like they could still be EDM songs. Let's look even higher and figure out if we can find any of these that are not EDM songs, so we can maybe find thresholds that make sense to get rid of some stuff. One thing that was interesting, I was going through instrumentalness, and one of these top 5 songs from instrumentalness, like near the very top, was Sandstorm by Darude. So I didn't actually end up cutting anything out of my data set because of instrumentalness, because of Sandstorm. In any case, I went through all of the different features and ultimately wrote up my conclusions here about what I thought needed to be excluded. For instance, for duration, I excluded things greater than 10 minutes or less than 2 minutes and 15 seconds. I won't go through all of this here, but there were some things that made sense to get rid of. So my first round of data cleaning got rid of some stuff based on those notes above. I had to drop a variety of duplicates, things that are showing up in multiple playlists, not only stuff that showed up in multiple playlists from the same genre, but also things that showed up in multiple genres. If they showed up in multiple genres, I don't want them. That means it's kind of ambiguous. I don't even want them in my data set. Also needed to adjust the tempo, and I got this from somebody on GitHub, jrobin2791. Basically, when the tempo is over 200 or under 100, it's really not even like a legitimate tempo, and it's probably in double time or half time, so we need to adjust it back to basically we divide or multiply by 2 to make it a reasonable tempo. You're also going to notice in this EDA that there's tempo that is way outside the prescribed ranges for certain EDM genres, and that's just something that we kind of have to live with. In any case, I went through these steps. Initially, I had 60,000 songs before doing this cleaning, and 7,000 songs from the Spotify recommendations. This got trimmed down to 55K and 5,600. Then I needed to balance my data by genre. This is class balancing. So this is like how I said before, drum and bass had only around 5,000 songs, and that means I needed to do random sampling on all of these other genres to get down to that level of 4,900, so that I had balanced classes for my modeling. Same thing here for the recommendations. Techno was the lowest at 500, and part of the reason for that is that I don't think techno is really a genre. I think it's something that, like, old people say, darn that techno, but it really kind of covers several different subgenres within EDM. So yeah, after balancing, you can see here we're at that 4,900 level for everything, and 500 for everything for the recommendation side of things. Then I ran some pair plots, just kind of looking for correlations and trying to figure out, is it going to make sense to do any sort of variable interactions, polynomial features, that sort of thing. Ultimately, this didn't prove terribly fruitful. It's interesting to see some of these correlations, but there's nothing super strong. If you want to read about, here I kind of zoomed in on some that seemed potentially interesting. And if you want to read about any of them, they're here in my GitHub, but didn't really result in a whole lot of action. This is where things did get a little more interesting. I was looking at box plots of the individual features separated out by their subgenres, and I wanted to do this to see, okay, is there anywhere where clearly these features are going to be a good feature for separation for classification models. Here you can see danceability's got some decent separation in the interquartile ranges in these colored boxes. Not so much for duration or energy, really. Instrumentalness had some good stuff going on, but we have some pretty wide distributions from practically 0 to 1. It doesn't feel like this is going to help very much. Key, not going to help. Liveness, not going to help. Loudness, maybe. We have a little bit of separation here. These are all things that can help in maybe the edge cases, you know. Time signature, no. But then we get down to tempo. And tempo is the clear winner in terms of this is going to be a feature that's going to help separate things into different genres. Here you see with drum and bass, you know, the entire box plot here really doesn't even overlap with any other box plot. Of course, you see we've got tons of outliers sitting outside of the whiskers. And, you know, I have two theories for that. Part of it is it's user-generated playlists, so some of this stuff might not be well classified. Of course, the vast majority of it looks okay, though. And then, also, I don't even know that the Spotify data is 100% reliable. Who really knows? But anyway, this does seem like it's going to be the most useful feature. We've got some nice tight box plots here. Hardstyle is practically a straight line. Good stuff. Valence, not so much either. So tempo was clearly kind of the one that we needed to dig into a little more. So what I wanted to do was look at what I was just kind of talking about there, the playlists, user-generated playlists versus the recommendations from Spotify. And what we see is similar looking distributions, but definitely much cleaner on the Spotify side. So what we see is that for instance, progressive house in purple, we see this kind of almost bimodal distribution, whereas down here we see a very clean, very tight distribution right around, 125, 130. And for some others, for instance, techno, like I mentioned before, techno is probably going to be a problem for us. We see this really long, flattened out distribution from the playlists, and from the recommendation side, we see actually the same thing. It really is kind of not a very specific genre. It doesn't have like any sort of prescribed tempo ranges or anything like that, whereas the others really do. And I've got some resources on that. This came from the Acusonus blog, and this kind of shows the prescribed ranges for house, trance, dubstep, techno. Techno you can't see is a pretty wide range, but not as wide as those density plots above. Drum and bass correctly at the high end, very similar to our density plots above. Hardstyle, this is a straight line. Hardstyle has one accepted BPM, no range. So yeah, I attempted to do some imputation that I'll show later to try to fix some of these things in the data, but it really doesn't work because you can't fix things that are going to then pop up in the real world. Doing imputation and fixing all of the tempos to what they should be, or excluding anything that's got a tempo outside of the range for its genre or tagged genre, really wouldn't work, and it hurt our accuracy in the models. But I'll show that later. Did need to create some dummy variables. These are for the categorical things, key, mode, and time signature. And then, again, pickled the clean data for use in the next workbook, which is the modeling workbook. And this one's massive. I won't go through too many of the details here. A lot of it is just playing around with different models to see what's going to work and what's not. I'll kind of breeze through this. You can see I imported all sorts of stuff from sklearn, also XGBoost, brought in the data. First did a train test split, 60% training, 20% validation, 20% testing. You'll see that I do this actually several times throughout the workbook because we need to split things in different ways. Did some transformations. I just normalized and standardized the data with min-max scaler and standard scaler for use in different models that need standardized data. Didn't want to standardize the dummy data, so I had to add that back in separately. And then for logistic regression, you do need some additional work here to make it work. So first thing I did was I did a baseline evaluation. This is just out of the box. What do these different models look like? So that's what you'll see here, just a whole bunch of different Bayes models, tree models, XGBoost, support vector machines. And ultimately, I put them all through cross-validation. And what this shows here is all of the different models, their training score, their validation score, and their generalization score. So you can see some of the highest scoring ones are XGBoost, Random Forest, and Support Vector Classifier. I also pulled forward logistic regression more so just out of interest than anything. And what I did on these 4 models was some additional hyperparameter tuning and cross-validation. So again, did some train test split, some normalization. And here, over the next few scrolls of the page, you're going to see some parameters, some grid searching going on, trying to find the best estimators for XGBoost, Random Forest, and for logistic regression. And support vector classifier. So that's all you're seeing here. More of that. Here's Random Forest. Some grid search stuff going on. All this code's available on my GitHub if you want to go find any of this. Here I did the same thing for recommendation data. I was really interested to see how differently it would score if I used recommendations rather than the user-generated playlists. Support vector machine, logistic regression. Okay. And then ultimately we get down to my model selection. XGBoost performed the best, and these were the parameters that produced the best accuracy score. And then Random Forest was close behind, and here's the parameters that gave the best score there. For N estimators, the best number of trees is more trees. So I stopped at 1,000 because it was kind of petering out. And ultimately, for my app, I decided to go with Random Forest. And the reason for this is that the best of the Random Forest models is actually using much less features than XGBoost, and it didn't require any pre-processing because the best performing model removed all of the dummies. So I didn't have to do any pre-processing on the data that I pulled, for instance, from Spotify recommendations in the actual app. I didn't have to do anything with the dummy variables. It was already kind of set up for the Random Forest model. I'll show a bit more about this later. Here's what I was talking about with imputing tempo values. So I tried imputing by genre. Of course, you can only do this on the training data and not the testing data, and it just destroys any accuracy because tempo is the most important of the features. And playing around with it, I try to only impute stuff out of kind of the broader range of what fits in EDM. Even that had a pretty big impact on the data. So ultimately, I just didn't do it. Here, I did imputation on the training and the validation data, which is obviously cheating. Can't do that. But I just wanted to see, okay, am I off base here? Would this even help? And it did. It actually provided the best of all validation scores. Am I frozen? Probably don't need my face anymore. So yeah, it provided the best of the scores, but it's not fair to do. So ultimately, I moved away from that. So on to the kind of the final model refinement. So here I did sequential backward and sequential forward feature selection. So sequential backward, it's removing one feature at a time based on which one's removal results in the best accuracy score going forward. So you take out the worst over and over again until you kind of get a full order of things, and the backward order of that list would kind of be a semblance of feature importance. Then I did it the opposite direction with sequential forward. So you start by finding out the single feature that provides the best classification model on its own. Then you loop through and try to add in one at a time based on which one, when added, improves the model the most. And then I kind of compared them back and forward. And here you see I printed out the best combos. So here this only had 11 features. The best one was 76337 in terms of accuracy. And then going backwards, the best was this one with 18 features, 764826. Sorry, this was going forward actually. Ultimately, I basically reduced all the features down to everything. I did include mode because it was already a dummy variable, but key and time signature were cut out entirely in this final model. I also did feature reduction on XGBoost, did that same forward and backward feature selection, and ultimately the best of them had 24 of the 27 possible features, so not a whole lot of feature reduction happened for XGBoost. Explored polynomial features as well. Adding a second degree really didn't have much of an impact positively at all, and adding a third degree was worse. So and this is just with simple validation, not cross validation, so take with that what you will. 79, actually adding a second degree hurt it, adding a third hurt it even more, so it wasn't a helpful exercise. Abandoned polynomial features. On to the model evaluation, starting with random forest. Here's our scores. Train score is nearly 100%, and the testing score is 76.4%, so it's obviously very overfit to the training data. However, this is still the maximum cross-validation score that I could get, and that produced a test score of 76.4. Here is the confusion matrix, and what we see is that, of course, techno is the big problem, right? Only 56% of the time this is normalized by actual, which means that these rows add up to 100%. So when it's techno, my model predicts that it's techno 56% of the time. Not great. It's clearly the worst of all the other genres. Dubstep's not great at around 70% either. And then normalized by prediction, so the columns add up to 100% here. We've got 63% of the time that I predict techno, it actually is techno. Again, the worst of all of them. Deep House is at 70%. Deep House kind of has a tempo that a lot of other genres can fall into. But anyway, techno is by far the worst. And so here we see the feature importances for our random forest model as expected. Tempo is at the top. Danceability and loudness were kind of the other two that seemed like viable candidates for an important feature based on just kind of our EDA. And then it goes down from there, getting less and less important. Pickled the model for deployment. And then here I wanted to just look into some other stuff. So this is the random forest model using Spotify recommendations rather than using the user-generated playlists. And we can see that it's much cleaner. This gives us a test score of 82% versus 76.5% for the user-generated data. So it might be better, but it's only 3,500 songs in total for our data set, so it's not as robust in that sense. And then for XGBoost, testing score came out just a little over 77%. Still, techno is the problem, and no matter what data we use, no matter what model we use, it seems to be that techno is the problem. And now quickly I'll show the code for the app itself. So Streamlit is a really nice library for building these little web apps. I was really pleased with how simple this ended up being. So you just import Streamlit. I needed to do all my Spotify stuff, different libraries that I'm going to need, the pickle. I ended up doing Plotly for my data tables because they're easier to mess with the formatting. I was struggling to do that with just kind of a normal data frame. Here I load in that pickled random forest model. This is the Spotify stuff. Gonna need your credentials, gonna need to sign in. Or this is actually a function to sign in. I just sign in like everywhere. You'll see in all my functions, I just sign in again. Just do it again. Don't mess around. Anytime there's a time that you need to grab some data, just sign in again so it doesn't time out on you. So these are the retrieval functions. You're going to recognize these from the other notebook. Get recommendations, get the tracks from playlists, get the audio features for your track URIs. Here we've got, these are the model columns. These are the ones actually being used in this random forest model. These are all the things that would have been used, but I cut out in feature reduction. Maybe in the future they'll become useful. I don't know. Here I'm imputing the median for any columns that have not a number. Not ideal. You don't want to have to do it, but it's not terribly important in this fun little web app. This is for dummies. This is actually not being used. You would need to create dummy variables for anything, for key or time signature, were those features to be used in this web app, but in this case we're not using them, so that function's not in use. And then I've got some other functions here. This is just kind of building the model data to be fed into this to make predictions, and this is predicting a single track. These are some consolidation functions that take recommendation seeds and take it all the way through to classification and return these data frames or data tables that you'll see in Genrefy. Same thing for playlist URI to the classification and a track URI to the classification. Then we get down here. This has to do with Streamlit formatting. So this is kind of just a layout. This markdown stuff is to give me that nice purple gradient in the background. That took forever to figure out. Then we've got some styling. This doesn't end up getting used actually. I can delete this. It was used before. And then some Streamlit functions. This one is to show the Plotly table. So this is used to show both this table and then also the detail table. It's the same function that gets called. And then we construct the pages. And this is where Streamlit is just so cool. So you've got your pages is going to be a select box. Choose your Genrefy tool, these three, and that corresponds to this little drop down here. Super easy to build. And then this is all sidebar stuff still. Sidebar, sidebar, sidebar. This is just kind of writing out how to use the app, information about me, that sort of thing. These are the available genres. This is what we're going to pass into our drop down here. So now this says, this is really cool. If pages equals recommendation classifier, build this page. Else, if it's equal to playlist classifier, build this page. If it's equal to track classifier, build this page. Again, super simple. That's just like, if you choose recommendation classifier, build this page. Really nice. And then within here, what you see is included in a little app at the top, or a little picture at the top. This left, right, middle is setting up columns for our stuff. So this is like a left, a middle, and a right column. That's what you see here. And here are the relative sizes of those columns. Then you've got, on the left side, this is setting up a form. So with this form, which takes these inputs, you see these are multi-select box for the genres, and these are text areas to add in those URIs that I showed you, and a submit button. And then if submit, which means if you clicked that button. So if this, if that, basically run the different functions and build it out. And then the same is true for the pages thing. If you click the button, build out the page, show the tables, same thing for the track classifier. So that pretty much covers it. Feel free to visit my GitHub or post any questions on this YouTube video. Happy to answer whatever I can. Keep in mind, I'm just a budding data scientist who's just finishing up a boot camp. Thanks.